Hello, pre-calculus students. In our last lesson, we learned how to find trig ratios of angles on a right triangle, which means that since we had one angle on the triangle was 90 degrees, the other two angles both had to be acute angles. But we know that there are angles larger than 90 degrees. So how do we find trig ratios for those? Well, on those, we're going to work with the unit circle. So we're going to go from the triangle, which was just kind of introduce those trig ratios. We're now going to look at trig functions of any angle by extending that triangle to a circle. So here's my length r, which is a radius. And there's x, y, so that point is x comma y. Well, we know that the cosine of this angle is x over r, the sine of this angle is y over r, and the tangent of this angle is y over x. And that's great, that's in the first quadrant, we're already used to that, we can see how it makes a triangle. But what do we do about second quadrant angles? So now x is a negative number, so my x is negative, my y is positive, and r being a square root is going to stay positive. Well, it turns out, and this angle in here is not theta, this angle out here is theta. Because remember, our angle starts in standard position along the positive x-axis, end at the origin, and it rotates, and if this is the terminal side, this is the angle through which it rotates, theta. Well, what is cosine of this angle? Well, it turns out that the ratios still apply. Cosine theta still equals x over r. You might say that, you could see where it would come from the triangle. It would kind of be adjacent over hypotenuse, even though you can't have a negative side of a triangle, but the idea is still x over r. So cosine is an x value. Sine theta is still y, opposite over hypotenuse. So it's still y over r, and tangent is still y over x. So these three ratios here, down here, they work in all four quadrants. So SOHCAHTOA only really works on triangles. Once you start expanding into the second, third, and fourth quadrants, well, then we need to think of, instead of opposite and adjacent and hypotenuse, we need to think of y, x, and r. This is a very important concept. Write this down. Make sure you understand it. We're going to be using this for a long, long time in this course. The idea of a reference angle. A reference angle is an acute angle that the terminal side of an angle makes with the x-axis. Make sure that you get that definition. Now let's take a look at what it means. Let's start here with a 30-degree angle. There we go. 30-degree angle. Now, would we all agree that this is my x-axis and this is an acute angle that the terminal side makes with the x-axis? So that 30-degree angle is its own reference angle. But now let's add 180 degrees to it. Let's go to 210 degrees, which is what in radians? Well, if this is 1 pi over 6, and you're adding pi, it would be 7 pi over 6. All right, so here's our angle down here, and you know that because these are vertical angles, these are both going to be 30 degrees or pi over 6. So this angle starting here on the positive x-axis, rotating through, and now this is my terminal side. So this angle in here is the acute angle that this terminal side makes with the x-axis. Notice that it's a 30-degree angle. So the reference angle for 210 degrees is 30 degrees. Well, what does that buy us? Well, it turns out that all the trig ratios over here for 30 degrees, sine, cosine, tangent, you'll notice that these triangles, even though I haven't drawn them very well, those triangles are congruent to each other. So this x distance has to equal this x distance, only this one's going to be negative. This y distance has to equal this y distance, only this one's going to be negative. And this r is going to equal this r. So the lengths are all the same. It's just the plus or minus that's different. And that's what's nice about reference angles, is I don't have to memorize anything for 210 degrees. I just have the same numbers for 30 degrees. We've already said the cosine is √3/2. The sine is 1/2. And the tangent is √3/3, 1/√3. Well, now over here, the cosine of 210 is going to be negative √3/2. The sine of 210 degrees is going to be negative 1/2, and the tangent will still be √3. So let's look at example. I chose a second quadrant angle here. So this is 150 degrees. Well, since it's 150 degrees, we know that this reference angle in here is going to be 30. So it's a 30, 60, 90 right triangle. And I know that then if that's 30, that the short side is going to be half the hypotenuse. And in the second quadrant, y is positive, x is negative. So what is the sine of 150 degrees, or the sine of 5 pi over 6? Y over r, it's 1/2. What is the cosine of 150 degrees, or the cosine of 5 pi over 6? X over r, negative √3/2. And what is the tangent of 150 degrees, or the tangent of 5 pi over 6? 1, it's y over x, 1 over negative √3, or negative √3/3. So how do we find these reference angles? Ooh, man, I've got stuff written all over the place here. So how do we find these reference angles? Well, as we've already pointed out, in the first quadrant, the reference angle is equal to the angle itself. And we say theta prime is just, we're not going to use that notation very much, but theta prime is the reference angle, and it's equal to the angle itself. What would it be in the second quadrant? So here's theta prime, because that's the acute angle that the terminal side makes with the x-axis. Theta is an obtuse angle. Theta prime is an acute angle. So how would we find theta prime here? Well, it would be 180 degrees minus theta. So when we had a 150-degree angle, the reference angle was 30 degrees. How are we going to do it in the third quadrant? So here's theta, and this shaded in area is theta prime, the reference angle. Theta prime is the entire theta minus 180 degrees. And then the fourth quadrant, how would we do it? This is theta prime in here, shaded area. Theta prime would be 360 degrees minus theta, or 2 pi minus theta. Using the book that we're using at the time I make this video, there's a checkpoint problem on page 294. And that problem said, to find the sine, cover all the rest of this up, find the sine of 7 pi over 4 expressed as a function of a first quadrant angle. Well, a first quadrant angle is going to be an acute angle. So here's 7 pi over 4. You'll notice that theta prime is pi over 4 because it would be 2 pi minus, which would be 8 pi over 4, minus 7 pi over 4. So that's a pi over 4 in here. But we're looking at sine, which is a y value. So this distance right here is the sine of pi over 4. This distance down here is the sine of 7 pi over 4, but it's in the negative direction. So we know it's not the same as the sine of pi over 4. It's either going to be the same or the opposite. In this case, it's the opposite. That's the deal with reference angles. All the trig functions, at least the absolute values, stay the same. The magnitudes stay the same. The only thing that'll change is a plus or a minus sign. So because we know that the sine of pi over 4 is positive root 2 over 2, we know that the sine of 7 pi over 4 is negative root 2 over 2. And then, how do we determine the cosine of negative 120 degrees? Recall that positive angles are rotated counterclockwise, negative angles are rotated clockwise. So here's 120 degrees in the negative direction. What is this reference angle down here? It's 60 degrees. So you can see I've drawn the two triangles. Now the question is the cosine of this angle equal to the cosine of 60 degrees or the negative of the cosine of 60 degrees? Well, this number is positive. There's the origin, so this has to be negative. So it's the negative of the cosine of 60 degrees, which is negative 1/2. Now on, if I were to give you a homework assignment that included number 16 in section 4.4, they say the point -410 lies on the terminal side of an angle in standard position. What are the 6 trig functions of that angle? Well, -410, I'm going to go -4 here, 10 up. So here's angle theta. What is the cosine of angle theta? Well, you can tell it's got to be negative. The sine's got to be positive, and the tangent has to be negative. So if we find r, that's 100 plus 16. R is the square root of 116. I can tell that 116 is divisible by 4. So I factor a square root of 4 out of that. And in simplest terms, it's 2 root 29 is this hypotenuse. So what is the cosine of theta, the sine of theta, and the tangent of theta? Pause and write those in now. And we'll go over those answers in class. Continuing on. Let's do some practice with reference angles. Remember that reference angles are the acute angle or the first quadrant angle that the terminal side of your angle makes with the x-axis. So if I look over here, 37 degrees, that's up here in the first quadrant. 37 degrees is its own reference angle. I have 3 more reference angles. If I give you theta in degrees, write its reference angle in degrees. If I give you theta in radians, write its reference angle in radians. Go ahead and pause. Write those in now. And we'll go over those in class. So let's take a look at a pi over 4 angle, or 45 degrees. And if I made a right triangle out of it, over 1, up 1, that's root 2. So the sine of theta is y over r, 1 over root 2, which is root 2 over 2. Now, that's a good first quadrant angle. 3 pi over 4 would be in the second quadrant because it's 3/4 of pi, and pi is a 180-degree angle. So 3/4 would be halfway through the second quadrant. 5 pi over 4, well, 4 pi over 4 would be pi, so 5 pi over 4 would be down here in the third quadrant. 6 pi over 4 would be 3 pi over 2. So 7 pi over 4 would be down here in the fourth quadrant, and 8 pi over 4 would be the x-axis. So we know that the sine of pi over 4 is root 2 over 2. What is the sine of 3 pi over 4? What is the sine of 5 pi over 4? What is the sine of 7 pi over 4? We'll cover those in class. All right, so this will make more sense to you later on, but any multiple of pi over 6, where k is an integer, so I don't want 3.7 times pi over 6, and k over 6 doesn't simplify. So in other words, 2 over 6, so 2 pi over 6, that's not a pi over 6 now, that's a pi over 3, because 2 over 6 simplifies. So, but 5 over 6, so 5 pi over 6, 5 over 6 doesn't simplify. Okay, so that one works. Let me pause this and let's see. Pause. Sorry about that. I've been making videos so long that the lights went out. So anyway, any angle that has this, where this is the case, will have a pi over 6 as its reference angle. Now, if you have a k pi over 4, and k over 4 doesn't simplify, so 2 pi, so it's got to be odd numbers. 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Those all have a pi over 4 as a reference angle. But 2 pi over 4 doesn't work because 2 over 4 is 1/2 pi over 2. That doesn't have a reference angle of pi over 4. So anyway, what these mean is if in simplest form, when you reduce all the fractions, you end up with an integer times pi over 6, you know, 5 pi over 6, for instance, then that angle will have pi over 6 as a reference angle. Anything that meets these criteria will have pi over 4 as a reference angle, and anything that meets these criteria will have pi over 3 as a reference angle. You'll see what that means as we apply it. So here are the pi over 6s within, within one revolution. Pi over 6, here you can see that if this is a reference angle of 5 pi, this is 5 pi over 6, it's going to have a reference angle of pi over 6. 7 pi over 6 has a reference angle of pi over 6, and so does this one. And 1 over 6, 5 over 6, 7 over 6, 11 over 6 don't simplify. So they meet the criteria for the pi over 6 reference angle. And I think it was in the, I don't remember if it was the beginning of this video or in the end of the last video. We started off with, or I gave you the most important trig ratio of them all, or the most important trig identity of them all. Cosine squared theta plus sine squared theta equals 1. Well, let's prove that. Well, cosine theta is x over r. Sine theta is y over r. Notice I put an equal sign up here because I don't know if it's true yet. I'm just not even going to touch this 1. All right, well, I've squared and squared. Now I have a common denominator, so I can combine them. And now what's x squared plus y squared equal? Well, that's r squared. So r squared theta equals, r squared over r squared equals 1. So what we've done is we've proven then that this identity is always, always, always true. So what if, we'll start with 30 degrees or pi over 6. I tell you that, hey, the sine of pi over 6 is 1/2. What's the cosine? Well, we know that sine squared theta plus cosine squared theta equals 1. Now, if the sine of theta is 1/2, if I square that, the sine squared of theta is 1/4. It's like squaring both sides of this equation. Some people will make a mistake and write sine of 1/4. No, the sine of pi over 6 is 1/2. If you square this, which would be sine squared of pi over 6, you square this, it would be 1/4, not the sine of 1/4. So then cosine theta equal, cosine squared theta is 3/4. What's cosine theta equal to? Well, it could be, remember that if that's squared, it could be plus or minus the square root of 3/4, which is root 3 over 2. Don't forget that possible minus sign. Now, we know that pi over 6 is in the first quadrant, so cosine has to be positive because that x value will be positive. So it is root 3 over 2. But if just similarly, if I'd have given you sine of 5 pi over 6 is 1/2, well, that cosine would be negative. Well, then there's problem number 23 in our current text that says, there's an angle theta out there. The sine is positive, and the tangent is this value. Well, in what quadrant, well, in what two quadrants is sine positive? Your y value. Well, that would be the first and the second quadrant. So is tangent positive, is tangent negative in the first or the second quadrant? Well, it turns out it's negative in the second quadrant because it's y over x. Y and x are both positive in the first quadrant, but y is positive, x is negative in the second. So it's a second quadrant angle. Aha. So we're narrowing this down. So let's draw a picture. If tangent theta is -15/8, then I need to draw a second quadrant angle that has a y of -15 and an x of, I'm sorry, y, it's -15/8, but because y is positive, it's really 15/8. You can see how that works. So here's my y of 15, my x of -8. That makes my radius, that's a Pythagorean triple, 17. Now, I don't know what theta is, but I know that its sine is positive, and I know that its tangent is -15/8. Opposite over adjacent, or y over x. So what are its 6 trig functions? Well, let's just zoom in here. Cosine theta is x over r, -8/17. Sine theta is y over r, 15/17. Tangent theta is y over x. And then the 3 reciprocals. Well, I think that's enough for this lesson. Have a great day.